Hi, so I'm going to probably split this up into a couple videos because it might be kind of long, but we're looking at the zoo project and the first part, which is the area of the triangle. Now, what this is showing is that any of these will work to find the area of the triangle. You don't need to use all three. So in this particular example, let's take a look here. One of the important things to note when we look at the labeling of a triangle is, sorry if it's not fantastic, but if this is angle A, which will be labeled with a capital, this is angle B, and this is angle C, then the side opposite the angle is the lowercase a. The side opposite the angle B is a lowercase b, and the side opposite angle C is going to be depicted with the lowercase. So if we're looking at this particular triangle, then we have B is equal to 117 degrees. We have side A as 2.4 feet. And we have side C as 2.6. So, since we have angle B and side A and C, we're going to use this here, the middle one, 1/2 AC sine of B. That will give us the area. So I'm going to plug that in, right? The area of this triangle is 1/2, equal to 1/2 A, side A times the length of side A times the length of side C times the sine of the angle with B. Whoops. Sorry, that's a B. Now we're going to plug it in. So 1/2 length of side A is 2.4 times the length of side C, which is 2.6, and then sine of 117. I like this particular calculator. I also usually find the sine first. I find that easiest. And I'm going to multiply it by 2.6 times 2.4. And then I like to go ahead and divide that by 2, which is multiplying it by 1/2. And we come up with 2.79, blah, 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 blah. Well, we're going to round to the hundredth, which is 2.78 feet. And since it's area, make sure you do feet squared. So that's how you would do this. Now in this case, you would have angle A. This is angle B over here, and C up here. So you have angle A is 102. You don't have side A, but you have side B, which is 234, and side C, which is 380. So you would go back and plug it into this first one, 1/2 BC sine A. So I'm going to pause it there, and hopefully that'll help you get through that. Now in part 2, you're going to be using this law of sine, or the sine rules. It's a proportion to find, to complete the triangle. So if you're given one angle and a couple of sides, you can find the rest of the angles, you can find the length of the sides, all of those. So the law of sines are right here. Side A over sine A is proportionate or equal to the length of side B over sine of the angle B. You don't need all three. You can just use two things here to solve the triangle. Again, so let's take a look at this example. Let me erase things. Okay, so I redrew this. It's not as lovely as the other picture, but remember we have A, B, C as the angles, capital A, capital B, capital C. The corresponding side is opposite. So side A is opposite angle A, side B is opposite angle B, and then C. So now, using the law of sines, I want to know what is the length of angle A. So in this case, they labeled it X, not to confuse you, but if I put side A over sine of A, which in this case is 68, is equal to, now I don't need to know C in this case because I have the information for B. So side B is 55.7 over the sine of 70, right? Oops, I need to put a dot there. So you see now, I set the proportion, and now I want to solve for x. It's not working. So, which in this case is really a. I'm gonna, since x is being divided by the sine of 68, I'm gonna multiply both sides by the sine of 68. So I have this, right? X equals 55.7 over the sine of 70 times the sine of 68. Okay, so now using the calculator, we're going to do this 55.7 divided by sine of 70 times the sine of 68. So 55.7 divided by, and then I go sine of 70 in parentheses times sine of 68 parentheses equals, and it's 54.95 on and on and on. In this case, we would round it up. We could round it up to 55. So that's how that would work. You could round up to 55, or you can go out to 50. Well, even if you rounded it up to the hundredths, it would round up to 55. So that's how you would do those. And in some cases, you may have to find, you'll have a side and have to find an angle, but you're still going to use the two of these proportions. Be sure that you are following the sine rule and that you're labeling correctly. You have the angle A, opposite side is labeled lowercase a, and so on. So hopefully that will help you with this next one. And I'm going to pause and go through one more part. This next part is kind of a proof of how you can use the sine and the length of the side to find the area. I'm not going to go through that right now. If you need additional help, let me know. But in the meantime, I wanted to go through this part to help you get started. I'm not going to do all of it, but using the proportions and the law of sines, the how to find an area of a triangle using sines. I want to get started on this because I think this is where students get confused. Okay, so looking at the zoo problem. Really, this is a giant triangle split into 3 triangles, and you're going to find all the lengths of the sides of the large triangle, and the smaller triangles, you're going to find the angles, and then eventually find the area of the whole outer triangle. The way to do that is to think of it as a puzzle piece, and we're going to do a little bit at a time. Sorry about my very terrible drawing. But now remember, if we labeled this, in this case we called this, we're going to take each triangle as a piece. I'm going to take this first triangle, ZGE, only looking at that. If I was to call this 37A, then side A would be 349. If I was to call this B, we don't know side B, which is fine. We'd call this C, and side C 235. So I can use these 3 things here to find this angle up in here, angle ZEG. So, remembering our proportion, side over the sine of the angle equals the side over the sine of the corresponding angle. So in this case, if I said 349 over the corresponding angle, which is 37, sine of 37 equals, I don't know this angle, up here, so we're going to call that X, because we're searching for this angle ZEG. And over the corresponding side length is 2, whoop, sorry, I did that backwards. 235 goes up here. And we're looking at the sine of X. We don't know the, excuse my terrible, I'm not very good at this. Okay, sine of X. So this is going to be slightly different. Okay, so the sine of X, our variable is X, so I need to get that isolated. But keep in mind that sine of X is actually one number. So what I did is I multiplied each side by the sine of X and then had to multiply this by the reciprocal. So this is what we're working on right here, this part. Once we did the manipulation, I have the sine of X, which again is one number, so I can't get rid of the sine to have the X by itself. That's one number. Equals 235 times the sine of 37 divided by 349. So I'm going to use my calculator here. And I like, for me it's easier to do sine of 37 parentheses divided by 349 and multiply that by 235. Oops. Damn it. Let's see. Times 235. Now, what I have that equal to is actually the sine of X. Now remember, what I want is the angle X. So there's this button. It's the inverse of the sine. You see the -1. So I click second. It's actually called the arc sign. Click on that. Equals. Now this is actually the angle in degrees. See that? 23.9 blah, 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 blah. I would suggest just going ahead and rounding it to the whole number. So in that case now, I know that this angle is, what was it, 24? 24. So now the easy part on this one is if the inside angles of a triangle equals 180, I know that 37 plus 24 plus some number equals 180. So let's go ahead and figure that out. I have 180 minus, what did I say? 24 minus 37. Oh, I can't remember that. Minus 37. So I now know that this particular angle is 119, which makes it really nice. Because guess what? These two angles are supplementary, which means they also equal 180. So now I have 119. So I know that this angle over here has to be 180 minus 119, which is then going to lead me again to having these angles. Being able, because once and I'll figure out one more for you, and then so 119, 180 minus 119 is 61. And what's nice again is I can use the inside angles to again find this angle. Then I can use supplementary angles to find this angle. And then I can find interior angles to find this angle. Once I have the angles, then I follow the law of sines to find for each, think of these each as an individual triangle to find each piece, right? Here's a triangle, and once I find this side here, then I know the length of this complete side. Then I go back and use, where is the area? Oh, then once I find all the angles and sides, then for the whole big outside triangle, I use one of these to find the area. And that's all I'm going to do on this video, because if you need more help, I will be available online on Thursday.